Hello everyone, I hope everyone is doing well when they see this video. We're going to start talking about our groups in the periodic table. So we've learned about our periods and now we're going to learn about our groups. So as always, I like to ask some questions. So the first question I have is, do brothers and sisters act similarly or not, and maybe why? So for you guys, just to start thinking about if you're a lot like your sister, if you're a lot like your brother, and why that might be. So for me, I would say my brother and I have very different personalities, but we act very similar. We have the same kind of what are called mannerisms, which are just little actions. We like the same kind, or we will tease each other in the same way. We will do a lot of things similarly. And then another question I had is, does it matter how much older or younger your sibling is? So my brother's only a year older than me, and so we are very close and grew up very close together. But I feel like even in families I've seen that have a lot of different ages, different siblings, maybe bigger age difference, they still act they still act very similarly. And so we'll talk about why I'm asking about families here in just a little bit, but But before we do that, we're going to go through our objectives for the week, or for the day. So our objective is to be able to name our 5 main groups of the periodic table. We want to be able to describe a characteristic of each group, be able to locate an element, and locate an element within its group. So this is a really good video to describe the groups of the periodic table, also known as families. Those are kind of what my questions were pointing to. But please watch this video now. It does a good job and will help you understand the rest of this video. So it's a short one today, short video, but it's a really good one. So a good review. We've went over this slide before. Our columns are in our periodic table are called groups or families, and that's because they have similar properties. They all have the same number of valence electrons, and then we even saw a video that helped us remember what our columns were. They're up and down, and then we drew a square for valence electrons. So our groups and families talk a lot about valence electrons. Then we have periods or rows, which we learned about, and those are elements that all have the same shell. And we had our rows, which we were going side to side, and they make a circle because they all have the same shell. But going back to our columns, our groups or families, so we call them families and groups. I like the term group a little bit better, but they get used interchangeably. The idea about the family is that our families all act the same. So if we had a family like my family, they might act like this group on our periodic table, and then maybe your guys' family would act differently than mine, being from a different country, so we would have a new name for them. So the idea is our first family, it's in column 1, group 1. First group or family name is our alkali metals. Our second one we're going to learn about is our alkaline earth metals. And then for column 3 through 12, we have our transition metals. And then we have our boron, carbon, nitrogen, oxygen family. Those ones we aren't going to focus on as much. We're going to focus on our halogens and our noble gases. So we also have our inner transition metals. Those are our bottom extra little part of our periodic table, but the 5 ones I'm going to have us focus on because they, I think, have the most distinct, the most specific characteristics are this alkali metals, alkali earth metals, transition metals, halogens, and noble gases. So let's start learning about each one. Our alkaline earth metals are in this first row. It's either it's group 1A or column 1. It's all the same. These are metals, but they're less dense than other metals. So that means they're not very well packed together. So they're a little softer. They break really easily, and they have 1 loosely bound valence electron, and they're extremely reactive. So because they only have 1 valence electron, a lot of times they will give that valence electron to someone else very quickly because they want to go down to have a full shell. They want to have a full shell. So their valence shell, the outside shell, just has 1 electron in it. So if they could give that away to someone, they would be stable and happy. So that is why they are reactive. They just have one. This is what some of them look like. We have lithium, sodium, potassium, rubidium, cesium, and francium. And I have another video for you guys to watch. This one is really cool. When I say extremely reactive, this is an example of what I mean. This is different people putting different alkali metals with water, and then they see the reaction. So we drink water all the time. We all understand how stable, how good water is for us. But just by putting a few of these elements in water, you'll see a big explosion. So that's fun to see. We already have our alkali earth metals, which is next up. These ones are shiny. We can see these are a lot shinier than our other ones, and they're very hard. They're very hard. They also kind of make more of a, I would say, rough. They kind of have more little pieces to them rather than like a nice solid cube like we could see here. We have a nice cube of sodium, but out here it's like strontium's kind of pieced together. So they look a little bit different. They have 2 valence electrons because they're in group 2 or 2A. The easiest way to do learn about our valence electrons is use the 2A. So we have 1 valence electron, 2 valence electrons. They form divalent cations. So that means that they give up those 2 electrons to other elements to become stable. So they're a little less reactive than our alkali metals because we need to get rid of 2 electrons, 2 valence electrons, not just 1 valence electron, but they still are very important. Our next group is our transition metals. So this is a wide range. We can see it takes up most of our table of metals part. So there's lots of different things. These are easily formed for wires. So when we talked about like the difference between metals and nonmetals, we said metals could be used for electricity. So that's what a lot of them are used for. They have high melting and boiling points. This group especially is less reactive and are more stable naturally. And there's a wide variety. The important part of these ones that I thought we should try to remember is that they're often used as a catalyst. So we learned about enzymes and catalysts in Partial 2, but to help refresh your memory, a catalyst is something that is used in a chemical reaction to speed up the reaction by lowering the activation energy, but it itself is not consumed. So that's are important. They are used in lots and lots of different things. Our group 4 of 5 that we're going to learn about is our halogens. So this is group 17 or 7A. This 7A means that we have 7 valence electrons in our group. So we have 7 valence electrons, and just like our alkali metals, our valence electrons want to be stable, and so you need to be at 8 electrons in a shell to be stable. So with us being at 7, we just need 1 more valence electron to get there. And because of that, these are also very reactive. They often bond with our alkali metals. So our alkali metals want to give up 1 electron, and our halogens want to get 1 and want to take 1 electron from someone else. So those 2 families often work well together. And they often form salt. A great example is sodium, which is number 11, and calcium, which I think is number 17. And they come together to make NaCl, which is table salt. So whenever we put salt on our food, we are putting sodium chloride or NaCl. And then our last group that we're going to learn about is group 8A or 18, which is our noble gases. So way over here on the far right. They are extremely stable. So because it is 8A, they have 8 valence electrons, and that is why they are very stable. All their valence electrons in their shell are there. So they're not trying to react with anyone because they're already happy. These are all different kinds of gases, and we can see they all have a different color in them, which is really cool. There's some really cool experiments to do with those. So those are our different groups. We have 5 different ones. I just wanted to keep going in depth about why they act the same way. It's called a family or a group, and it's they act the same because it's all about valence electrons. So these are 3 different elements from our alkali metals, so they all have 1 valence electron. And so each group, since they have the same number of valence electrons, will react with other things very similarly. So each one of these that you put in water will start to catch on fire and then even explode, all because they have 1 valence electron. So let's start practicing how to classify these. So we have even some nice colors here. So we have our alkali metals, alkali earth metals, and then our transition metals are here in this color. And then we have our noble gases, and then our halogens aren't quite labeled correct, aren't quite color coordinated, but there is a group up here and label up here. So iron, Fe, would be in which one of those 5 groups that we learned about. So let's find Fe on our periodic table. After some practice, you'll just be able to find these a lot easier. So Fe is number 26, and so it would be a transition metal. Br, let's find that over here at number 35 on our table, is bromine. So it would be a halogen. It's in our halogen group. We have magnesium. Mg is over here at number 12. It is in our alkali earth metals. And then we have helium, He, number 2 on our periodic table, and that is a noble gas. So the only one example we didn't do was something from our alkali metals, but we have seen our fun video of exploding those in water to help us remember those. But I could ask you guys to do something like this, and we will likely work through a worksheet or some examples like this, but it's a pretty easy idea. You just have to be able to find our element on the periodic table and then remember which group it's in. But if there are any questions about this, please let me know. And if there's anything else I can do, please reach out. Have a great day.